In this lecture, we discuss interrupts. Before going to start interrupt, let me explain what's the stack. Stack is a section of memory having one address register. Now, if you see here, a stack is a container of objects that are inserted and removed according to the last in first out principle. Now, if we wanted to insert a data onto the stack, stack is nothing but what? Memory, set of memory locations. Now, these memory locations are addressed by the one address register that is called a stack pointer. Always a stack pointer holds the top of the stack. Now, whenever we want to insert an element, then that will be inserted onto the top of the stack. Whenever we need to take the data, remove the data, then the top of the data is removed first. This is called LIFO, last in first out, which the element is placed last, that will be taken out first. And this insertion can be done by using the push operation, push instruction, and removing of the data, retrieving of the data can be done by using the pop operation. Now, next topic is subroutine. Subroutine is a small program written separately from a main program to perform a particular task that may repeatedly required in the main program. And always this subprogram is called into the main program by using the call instruction. Here you can say call instruction, call and address we specify where the subroutine is written. That address we have to mention in the main program. Whenever this call instruction is being executed, it will go to that subroutine and it will execute how many number of instructions are there. It will execute instructions one by one. And the last instruction is written instruction. When written instruction is being executed, again it will come back to the main program. This is about the subroutine. Now we will discuss the interrupt. Already in the previous lecture, so we have discussed the different types of modes of data transfer. Now in the main program, if the program is written, in that program, if the microprocessor is needed the data or microprocessors want to send the data, then data transfer, if it is taking place, then in this program controlled IO mode, processor continuously monitors the status of the device till the transfer completes. During this period, when the device is not ready, that time processor will not do anything. So thereby what that processor efficiency is reducing. So to not to waste the time, so we have another approach that is nothing but interrupts. Whenever the device is ready, then the device will send the interrupt signal. Meanwhile, the processor can do some other job or it can execute some other program. Now here we will see the interrupts. Interrupt is a signal that requests the processor to suspend its current execution and receive and service the occurred interrupt. To service the interrupt, the processor executes the corresponding interrupt service routine. After the execution of interrupt service routine, the processor resumes the execution of the suspended program. Now here, interrupt is nothing but if IO devices are ready to send the data, receive the data, then the IO devices will send some hardware signal. For that separate line is there in the, now we have already discussed the control bus. One of the line is meant for this interrupt signal, and it will send the interrupt signal to the processor, and the processor will suspend the current executing program and it will go to the ISR. Then what is this ISR? It will execute the ISR. What is this ISR? ISR stands for interrupt service routine, and it is a specialized subroutine. Now already just now we have discussed the subroutine is nothing but a set of instructions again. Now this ISR is also set of instruction that handles the interrupts generated by the hardware or software events that require the immediate attention from the processor. Now here hardware and software. Hardware means what? IO devices. When the IO devices are requesting a processor to attend, then it is called a hardware interrupt. Software interrupts we will discuss in the later in the forward lectures. Now what happens when the interrupt occurs, that we will see here. Now this is the user program or main program. It is having 1 to n number of instruction. Now in between, if the interrupt is occurred, now for example, at the ith instruction, if the interrupt is occurred, then processor will stop executing this program and it will execute the ISR program. And after completing the execution of ISR, again it will come back to the main program, and where it will stop, where it suspended the program, again from that instruction onwards it will execute. This is actually what happens inside. But what are the steps involved when it is going to service the subroutine? And now here I said that again it will come back to the main program where it suspend. Means how the processor knows that again it has supposed to come back to the I+1 instruction. Now for that there is a mechanism inside. Now if at the ith instruction, if the interrupt is occurred, then the first step is it will complete the execution of the ith instruction. It will not immediately leave and go to the ISR in between the ith instruction. It will complete the ith instruction execution, and after that it will save the, now I+1 address is stored by what? PC, program counter. What program counter do? Program counter always holds the next execute address of the next executable instruction. So whenever this ith instruction is being executed, that time the PC is holding the I+1 address, instruction address. So when the interrupt is occurred, then it will complete the execution of this instruction and it will store the I+1 address. That storing may happen onto the stack or some special registers. But most of the computer, most of the processor, it will store the program counter data onto the stack only. And also it will store the status register content. Now in a basic operational concepts, we have studied the different register for and how, what for, and how, what happens inside the processor when the instruction is being executed. At the time I have explained only ALU. Along with the ALU, one more register is there, that is the status register. It will indicates the status of the processor when the instruction is being executed. Now those status is nothing but it is consisting of some flags like a carry flag, sign flag, zero flag, overflow flag, like that, parity flag, like that. Few flags are indicated by the status register. Now if for example addition is taken place, if any carry is generated, that carry will be set on the status register. Okay, so that a status register also saved onto the stack, and after that it will execute the ISR. And in the ISR also last instruction is written instruction. When the written instruction is being executed, then again it will go to the stack and again it will place the I+1 address onto the PC, and it will store the status register onto status register content from the stack to the status register again, and it will executes the remaining program from the I+1 instruction onwards. It will start executing. Now this is what happens when the interrupt occurs. Now these are the basic steps involved in the interrupt topic, that is the interrupt latency. This is nothing but the delay between, or this is nothing but the time between the interrupt received by the processor and the start of execution of the interrupt service routine. Now this is happens because of whenever the interrupt is happen, then the memory transfer takes place. Nothing but what? It is storing the PC value, it is storing the status register content onto the stack, and also in few processor it will also store the accumulator and few important register content also onto the stack. How much content it is storing onto the stack, depending upon that the delay takes place. To reduce the delay, most of the processor only the PC value and the status register values are stored. Now, if more number of IO devices are sending the request signal to the processor, then which device ISR is being executed, that's supposed to be known by the device. So for that, processor will, after receiving the interrupt signal, processor will send the acknowledgement signal to the particular device. Means what? Which device ISR is being executed, that device, for that device, it will send the acknowledgement signal. Now this is the hardware, interrupt hardware circuit. Now this is a processor IC, and in this IC, one of the pin is interrupt pin. And whenever the interrupt is equal to 1, then the processor understands that there is an interrupt occurred. Then now here, these are all nothing but these switches we have indicated, these are all nothing but consider IO devices. Now this is the device 1, device 2, like that n number of devices are connected to this INTR bar line. This is an active low line, and which is connected to the VDD supply. This is a pull-up register. Now if all the switches are opened, means what? No input device is requesting the processor for the service. Means interrupt signal is not generated. That time what happens? We see, if that interrupt signal is not generated, means what? All switches are open. If all switches are open, means whatever the supply is provided here, if VDD supply is provided, means what? This is considered as a logic 1. Then the VDD, this logic 1 is available on this line. INTR bar is equal to 1. Then now after this inverter NOT gate, then INTR is equal to 0. With this, processor understands that there is no interrupt signal generated. Now if any one of the device is sending the interrupt signal, then switch is closed. If the switch is closed, means what? Sending the interrupt signal. For example, if the first device is sending the interrupt signal, then the VDD signal is grounded by this switch. Now whatever the current is, the current will flow to, it will go to the ground. Means what? Here the complete signal is grounded by using this switch. Means now on this line, the signal value INTR bar value is equal to 0. Now if this INTR bar is equal to 0, after this inverter, INTR is equal to 1. If the INTR value is equal to 1, then the processor understands that interrupt signal is generated. Now this is for the only one device is sending. If many more than one device is sending the interrupt signal, then if this switch is closed, this switch is closed, and so on, many number of switches are closed, then what happens? If any one of the if one switch or any more than one switches are closed, then this line value is equal to 0. Why? Because this VDD signal is grounded. Wherever the switch is closed, through that switch, the value is, the VDD will be grounded. Thereby what? INTR value is equal to 0. INTR value is equal to 0. If more number of switch devices are on, that time INTR will be calculated by using INTR 1. This is nothing but not the arithmetic addition. This is a logical OR. Logical OR means what? In the truth, if you remember the, try to collect the OR gate truth table. If more than one input signals are logic high, then the output will be high, logic high. If more than one devices are sending the interrupt signal, then also at the time INTR is equal to 1. If one device or more than one device sending the request signal, then INTR is equal to 1. This is the interrupt hardware circuit. Now by using this line, the IO devices will send the interrupt signal to the processor. Now with this, in the next class lecture, we will see the remaining interrupt concepts.